Hello and welcome to our webinar Automated Production of Large Parts from Iceland. My name is Konstantin Friedl and I work at the technical sales in the field of chuck parts at EMAG. My colleague Bernd and I will present you in the next 45 minutes our solution for big parts, automation solution for big parts. Bernd.
A warm welcome to our webinar from my side as well. My name is Bernd and I work in the same team as Konstantin in the technical sales department for turning machines at EMAG. In our webinar, we show you the possibilities of automation with our machines and exciting realized projects for automated production of large workpieces. What about questions during this live webinar? Of course, you have the opportunity for using our chat function during the whole webinar, which everyone can read, or the question tab function, where we can receive and answer your message directly. If a question goes too much in detail, we will contact you after the webinar to answer your questions. I will now briefly go into the table of contents so that you can get a small overview of the topics we would like to present today. We have two machine series, the VL series. This is our modular standard machines with short delivery times. And on the other side, we have the VSC series. This is machine for customized solutions and applications for our customers. And for both, we will present you the automation solutions. We will begin with the VL series, and therefore I will give the word to my colleague Konstantin.
Thank you, Bernd. Here you can see a small overview of the VL series. The VL machines are the standard lathes at EMAG. I will briefly describe the different series. In this slide we see the VL2, VL4, VL6, VL8, which differ only in the component size. In this slide you can also see a section from the working area of our lathes. On the right, the turret with 12 places and the possibility of driven tools. For completeness, you can see the technical data such as chuck diameter, workpiece diameter and the travel feds in X and Z axis. Not to forget, we also have as an option a Y axis if necessary for the process. Today, however, we only want to talk about the VL8 and our automation solution. In the previous slides, we discussed the workspace and the possibility size of the workpieces. Now we show you the exterior structure of the machines and the associated components. Oh, sorry. There? In the front, the workroom door. On the right side, the control panel. On top of the machine, the spindle, the vertical spindle. On the right side, the electric cabinet. And behind the electric cabinet, the fluidics cabinet. Also on top of the machine, the extraction unit for the workroom and the cooling unit with the black fan. On the left side of the machine we see our so-called O-type conveyor, which is our internal standard automation in the VL series for manual loading on drag frames or workpiece specific pallets. Now I give the floor to Bernd.
Thank you, Konstantin. I will follow with the automation solutions for the VL series. And therefore we have prepared also a 3D animation. As we have just seen, the O-type conveyor is the standard solution for internal automation on a single machine in the VL series. If a machine is interlinked with a robot cell or several machines are connected together, the L shuttle is used for automatic workpiece loading of the machine. Here you can now see our standard robot cell that can be attached directly to the machine. Furthermore, there is the possibility to add a second machine, then the robot supplies both machines. The interlinking of machines can also be carried out via our in-house automation system, the so-called track motion. This track motion is a solution for 2 to 4 machines. The integration of other units, for example, measuring or marking station, is also possible. The track motion travels through the automation tunnel of the machine on a railway system and transports the workpiece from one machine to another with an NC-controlled trans-lift unit. The workpiece can also be turned between the stations. The in-feed and out-feed conveyor are also controlled by the track motion automation system. This was the theory. Now we have the first realized project. This is only one machine with this O-type conveyor, but it has an interesting solution because we have the possibility for complete machining of the workpiece in 2 clamping positions on one machine. The loading and unloading is with our standard automation, the O-type conveyor. With a turning station behind the pickup station, it gives us the chance to produce OP10 and OP20 if the diameters are similar, such as here in the example. As soon as the spindle has placed the OP10 workpiece, the station turns the component for OP20 and moves to a lower position so that the spindle can grip the part. After OP20, the spindle places the component on the conveyor again and moves out of the machine. Here you can see the raw and the finished machine parts. The next example is a line which consists of 2 machines of the type VL8. This is a complete turnkey solution, a solution with a linear robot that can move in the axis. We have as workpiece a ring gear, and the machining is a hard turning. The line consists furthermore of a missing part detection, a position detection, 2 SPC stations, 1 raw part pallet and 1 finished part pallet. Important to know is that both machines have the same machine content. So we have 2 machines with an operation 10. And therefore we have also a video prepared. Before I started, I would like to explain that this workpiece must be aligned between the tooth flanks of the gear. Before this workpiece, it must be orientated. In this case, a laser is used. Now I start the video. First of all, there's an arrow proofing by camera attached to the robot. Then the picking up of the workpiece, and here the checking of the gear orientation with help of the laser. Then the orientated part is picked up and the toothing with the clamping device. Now you see the hard turning of the workpiece. After machining, a new raw part is loaded on the shuttle and the finished part is being unloaded by the robot. And for the next example, I will give the word again to Konstantin.
Thank you. But we have a question from our audience. What is the difference between wheel 8 and wheel 400?
Good question. I can answer this. The wheel 8 machine and also wheel 2, 4, 6, they have a fan control. And the other machines, the wheel 100, 200, 300 and 400, they have a Siemens control. That is the only difference. And here we have the same machine.
Okay, thank you.
You're welcome.
In this example, we show you a video from wheel 8 with the robot, with a robot cell in the middle of the line. Loading the raw parts. And now a visual position detection with the camera attached on the robot. In the next step, we go to regripping unit to turn around the workpiece. And now the component is placed in the OP10 on the raw part pallet. Unloading the finished part in OP10 from the shuttle. Here you can see how the workpiece is picked up by the pickup station directly with the spindle. Now let's jump right into the finished part measurement with our internal test probe. And we measure the inner diameter. Now we drive to the pickup station for unloading the parts on the workpiece pallet. Again, turn around the workpiece for OP20. And place it on the shuttle for OP20. After loading, we unloading the finished part on OP20. In this case, we have an external clamping on the OP20 in 2 planes. The OP20 part is also unloaded directly. We have taken out of the machine. Clean staging of the finished part . After the cleaning, we drive again to the regripping station for turn around the part. After this unit, we are loading the finished part onto the pallet. And here we have the compare of raw and finished part. In the next example, we have a line concept from 2 VL8 machine, 1 robot cell, 1 SPC station, 2 raw part conveyor and 2 finished part conveyor as a complete turnkey solution from EMAG. Here we have a simulation of the layout shown above. EMAG has the ability to use the simulation to analyze sources of error, increase capacity, and determine the use of buffer strategies through the different configuration so that the best possible availability is achieved. And now we go to the VSC series. And then, Bernd, please.
Thank you, Konstantin. Thank you for the last example. This is an important tool, the simulation, to get the best availability for our customers. To start with the VSC series, the C in the name of the machine stands for customized. These machines are intended for customer-specific applications. What does this mean? First of all, I can show you on the right side here. This is a work area with our standard turret with 12 positions. And of course, the possibility of driven tools. You need these driven tools for milling or drilling operations. However, there is also the possibility of implementing special applications with this VSC machines. For example, on the left side here, you can see a multi-head drilling unit. Multi-spindle was mounted instead of the standard turret. This was removed, and the unit is only for drilling and reaming. Furthermore, the machine can be equipped with an additional milling spindle. You can see this in the middle. Here, for example, you have the possibility to make a power skiving operation.
Done. Sorry. We have again a question to automation in the VL series. Up to what diameter can track motion be used? Yeah, answer this, please.
Yes, the track motion, our internal automation system, it can be used the same diameters than the machine. So, for example, when you have a VL8 machine, the maximum clamping diameter is 400 millimeters, and of course the automation system can also handle parts with maximal diameter of 400.
Oh, it's clear. Thank you.
You're welcome. Okay, then we go further on. Here you see the technical data of the machines. We have 4 machine types, different sizes. VSC 250, the VSC 400, the VSC 450, and the VSC 500. All machines are available both with a single spindle and with a 2-spindle version. This is so-called duo solution. For you as customer, the maximum workpiece diameter is important for you, and you can see it. We can go up to 440 millimeters for our biggest machine, the VSC 500. Today we want to take a closer look to the sizes 400 and 500 and show our implemented automation solution for these machine types. First of all, we have prepared a 3D animation to show you and describe the machine itself. First of all, at the front you can see the workroom door with a view inside the workroom, and on the right side the control panel. Here on the top view you can see nice the spindle, which is arranged on a pickup station, always in vertical position. Now you see the control cabinet, and in the back the chip conveyor that can also be arranged to the left or to the right side of the machine. We have then the fluid container on the left side of the machine with all pneumatic and hydraulic units. And on the top we have an extraction unit here on this side, and the cooling unit also on the top of the machine. Important is also this automation tunnel. This is in the backside of the working area, and in this automation tunnel there is space for the workpiece conveyor belt. We call it the shuttle. On this shuttle the parts are transported into the machine to the spindle, which picks up the workpiece with the help of a chuck. And now we explain how a single machine becomes a duo machine. A duo machine consists of two separate work areas. We have two individual machine beds which are integrated into one machine together, but with only one control and energy container. And the big advantage is these two separate base bodies prevent transmission of vibrations during the machining. Of course, these two separate spindle boxes have universally movable in all axes, so they are not coupled. You can do operation 10 and the other operation 20 in the other work area. The turning of the parts between the operations take place outside the machine. And this machine is often used when the customer has little space available on his shop floor, because we have the smallest space requirements for complete machining of a part in two clamping positions. For the next automation solutions of VSC series, I will give the word to Konstantin, and he will present first solution. Thank you.
Here we can see a simulation of different automation solutions. A single machine with shuttle left, possible also to the right. The shuttle can be loaded directly via robot or via an EMAG gantry loader with a loading and unloading conveyor. In this example, with one gantry loader, we have the option of machining up to 4 operations, where we can have the flow direction from left to right. The component would be transferred from the gantry loader to the machines via in-feed conveyor, where the process OP10 and OP20 are performed. The gantry loader then collects the semi-finished part and place it on the shuttle into the second machine, as the right machine, where the operations 30 and 40 are processed. The finished part is picked up again from the gantry loader and placed on the outfeed conveyor for unloading. Here we see a short simulation from above. On the left, you can see the dual machine with a shuttle and the gantry loader and the infeed and outfeed conveyor. The sequence is the gantry takes a part from the infeed conveyor and places it on the shuttle. The gantry takes the OP10 finished part and places it on the pallet of OP20. It then picks up the complete finished part and takes it to the finished part conveyor. Here again an automation example from a VSC 400 DD machines for the truck differential housing. It's a complete machining line. We have here 3 VSC 400 DD machines, 2 gantry loader, 2 SPC drawer, 1 row part conveyor, 1 finish part conveyor and 1 cooling system. It's a complete turnkey line. Machines and automations are complete from EMAG. Here you can see how the blank is gripped with a gantry loader and the orientation is determined by a sensor. The workpiece is pre-oriented and placed on the pallet. Now we drive into the machine with the shuttle. The sensor performs the fine orientation in the clamped state. You can also see a small section from the machining process. Milling the groove, deburring the groove, and broaching the groove. After the machining, the part is placed back on the shuttle and moved out of the machine. The part is turned around and placed on the shuttle OP20. Here we can also see a small section from the machining process, such as turning, gear hobbing with a fixed side spindle. At the end, a quality check is carried out with the internal measuring probe. Here only the lengths are checked. So, and we have again a question from our audience. It is possible to integrate more machines into the line VSC series?
Yes, of course. At the moment we see examples for the 2 machines, but it is also possible to integrate more machines, so 3 or 4 machines. Normally, a workpiece, the complete machining of a workpiece needs 2, 3 or 4 setups, and therefore you need the number of machines, and all EMAG solutions can handle this. If it's a robot cell or automation with a gantry loader, we can integrate more than 2 machines, of course. Yeah. Okay.
Thank you.
Yeah, good question and good next example, because here you can see a production line for machining of truck wheel hubs. This is a bigger line with in total 3 machines, 2 VSC 500 duo machines and 1 VSC 500 machine. And I will now guide you through this line and show you the raw part is placed on this in-feed conveyor and moves to this position. Here we have a stopper and a separator that this transfer unit can pick it up and brings it to the shuttle of the OP10. The shuttle transfers it into the machine where the spindle can pick it up and machine the part. After machining the part, the shuttle transfers it to the end position, and the first gantry loader here picks the part and put it on the shuttle of OP20. When OP20, if there is an error or a tool change has to do, then the gantry loader will put the parts on one of these buffer places that the OP10 machine can work further on. And in a later stage, you can pick it from these buffer stations. So we guarantee that the line never have a stop. Here you have also the possibility to put out a part for an SPC control. And here is the SPC drawer. You can put it out and after checking, put it again to the line. When we go here to the OP20, we have also a double spindle machine. And after machining of OP20, the shuttle brings it to this position. First of all, the second gantry loader now brings the part to a measuring unit in this place. So 100% measuring is here necessary, and to check if the part is okay or N-OK. If it's okay, the gantry loader brings it to the OP30 shuttle. When it's N-OK, here is an N-OK drawer to put the part out of the line. Now we are in OP30. The OP30 is a single machine. The reason is because the cycle time is only half the time of OP10 and OP20, and so we have only a single spindle and do not need a dual machine at this place. After machining OP30, the third gantry loader picks the part from the shuttle, first of all to a cleaning station to blow off the chips. When the part is cleaned, we have here a marking station where a needle marker puts the data on the workpiece. And at the end, the gantry loader placed the finished part on this outfeed conveyor, and you can put on the parts at the end. So a nice and interesting example how you can combine VSC machines with gantry loaders. The next example, we will show you a video of our next bigger line. How here we see a large line for the machining of brake discs. Usually brake discs are turned and drilled in 3 or 4 setups, and we use therefore a VSC 400 duo machine. From the in-feed conveyor, the parts are pushed via a pusher onto the shuttle for the first operation. Now you can see the machining of OP10, the pre-turning of the first side of the brake disc. The parts are then pushed back on a conveyor by the shuttle and turned with a double gripper and placed on the OP20 shuttle. Shuttle brings it to the pickup position, and in the OP20 the second side is pre-turned. You now see in the next tool how both brake surfaces are turned at the same time with a double tool. After OP20, the parts are pushed again onto a conveyor and then finally pushed onto the OP30 shuttle. And in the OP30, the last operations, the inner contour is turned and also the holes are drilled. Finally, the parts are going into a laser marking station. Here, for example, a barcode is applied. After laser marking, usually a measuring station follows, and finally the component is balanced. And for the next example, I will give the word again to my colleague Konstantin.
Thank you, Bernd. It's really interesting. First of all, we have a new question.
Okay.
Has the line for the wheel hubs actually been implemented in this way? I think it's for the slide, for the big layout.
The layout, yes, it was not only a layout. This line was built. We have mounted in our shop floor and is already delivered to customer and is now producing. So it's a realized project. Yes.
Thank you.
You're welcome.
In this slide, I realized example. I will show you the layout and my colleague will then show you the real video. Here we see two VSC 500 Duo and one VSC 400 Duo machine. In addition, we have 3 in-feed conveyors, 3 storage boxes, 1 robot that sit on rails and is movable. Furthermore, 2 cleaning station, 1 needle marking station, 3 turnaround station, 1 changing station for robot grippers, 1 SPC and 1 locate drawer. So we have installed everything you need for automated production in this line. We will now show you a small extract of this layout in real life.
Thank you, Konstantin. Yeah, here you see the production cell from the top view. A nice overview of this line. And when we start the video, you can see the workpiece is gripped from the in-feed conveyor and first of all is placed on the OP10 shuttle. The shuttle takes the component to the pickup station where it is picked up by the spindle. We only show the automation, not the machining. After OP10, the part is placed on the shuttle and transported out of the machine, where the robot brings the workpiece to the cleaning station. And this happened in clamped state. So the robot clamped the part and the cleaning station blow off the chips. You can also see here the overview and the second cleaning station in behind. After that, the part must be recrypted. For this, there is a turning station on each machine, and the workpiece is placed on the fork and then recrypted by the robot. To put on the part back on the shuttle on the position for OP20 to turn and machine the other side. We only show the automation and not the machining content because cycle time is over 15 minutes and we want to concentrate on the automation. That for information. After machining, the process is repeated. First, the part is blown off again. Now it's the finished part, and the blow-off process has to be that no chip is on the part. Then again, the part has to be turned and recrypted by the robot. Here you can fly with the robot. Nice animation. The next station is a needle marker. Here there can be marked workpiece data, like the type of the workpiece, or information of production, like date or time. Finally, the robot moves to the storage basket and places the finished part there. So that was our last automation example for large workpieces. And before we come to an end, the question to Konstantin, have we any questions?
Yes, one, I think this is the last question. What is the weight of the crown wheels? What you see in the video?
In the last video, the crown wheel, the weight was, I think, 70 kilograms of the raw part.
Mm-hmm.
And interesting, the finished part has only 50 kilograms, so we are making 20 kilogram of chips in these two operations. So this is also a lot.
This is a lot. Good. Okay. Then?
Do we have another question?
Yes, we have another question. If you want to, well,
can you read the question?
The show it. Okay. If you want to replace a series of lathe to machine a ring gear with a broaching machine already positioned and impossible to move with EMAG automation, will be it possible? I think the question is go a little bit too much into detail, and we can answer this a little bit later.
Yeah, we will answer it after this webinar.
Yeah.
It's necessary to know the broaching machine, which is already in use, and if we can handle this with EMAG automation. Yeah.
Yeah. Okay, I hope you enjoy our webinar.
Thank you very much for watching, and see you in the next EMAG webinar.
Thank you very much. Bye.
Have a nice time.